So introduction to pretreatment, this is kind of just the core definition. It's to prepare a substrate with the optimal paint bonding characteristics for a desired application. So what does that mean? Well, to achieve this, there are really two fundamental things that need to happen. One is a clean surface. So essentially you want that surface to have no oils, waxes, grease, metalworking fluids, rust, or any contamination that may get on any type of metal during transport, fabrication, any processes that happen. So that's number one. Surface needs to be clean in order for that kind of optimal paint bonding surface. The second part is a surface interface that actually has paint bonding characteristics. So an example of this is the actual conversion coating, which is what some of the chemistries react with the actual metal and deposit something on a microscopic level. So why do we need to achieve these two things? This is what happens when it's done extremely poorly. So coatings in the industry, and the picture is quite blurry there, but shows up better on my screen. But essentially it's to avoid corrosion. Anyone that's manufacturing a product that gets painted goes into a field environment that can have a variety of exposure, which I'll talk about in a little bit. But having paint appear to be rusty or have poor adhesion, a big thing with this is reputation from a company. They paint a product so it looks aesthetically pleasing in the field, but if half their product ends up looking like this, when people associate this brand of whoever made this with this type of quality, it can really be a detriment to that company's perception. So we always look at pre-treatment as a process in general. So it's always a sequence of steps, and each step actually does have an important purpose in the process. So it can be obviously as simple as 2 stages. Again, with any of this type of process, we still are needing to achieve those 2 things we talked about earlier, clean surface and a surface that has a conversion coating. So depending on a variety of factors, it can be as simple as 2 stages, but also up to 14 stages. So example of that is traditionally in the automotive industry, since it's such a high performance and long lasting environment, a lot of those systems were 14 stages of pre-treatment chemistry and rinses, just because the requirement for performance was that big. So that would be a combination of like various types of cleaning, various rinses, various conversion coatings, final sealers, which all kind of add up into those 14 stages. So when you're looking at selecting these actual processes, it really comes down to what the end performance requirements are and what the incoming substrate is. Those are kind of the two big factors in determining if you can get away with going with just 2 steps, or if you need to be in a very complex multi-step process. With any chemistry, there's kind of the 4 key variables that you can play with. So that's time, concentration, pressure, and temperature. So in any application, those are kind of the key parameters that can be manipulated to achieve a result. So when I talked about the designing your process and the number of steps, this is one factor that really needs to be considered, or multiple factors that need to be considered. So in the end, where are your parts going? So if you look at this list, they can be going to a variety of environments or situations that can make it pretty harsh for corrosion, either harsh for temperatures, high or low, as you can kind of see there, freezing thaw cycles, exposure to road salt, ocean salt. Salt is highly corrosive to pretty well any type of metal. So if you're going to be selling something that's going to be sitting on a resort on the ocean, you're going to need a more extensive process than if you're selling something that is going to be permanently indoor in a fixture inside of a building where there's no moisture, there's no sun. So these all play a big factor in how many stages and types of chemistry. So we kind of touched on this, but these are the key terms that relate to pretreatment. So in any application, these terms will come up when talking to customers or dealing with the lab. So titration is essentially the measurement of concentration. pH, measuring the acidity or alkalinity of the chemistry. TDS also is known as total dissolved solids, so the total minerals and contamination that are in, typically that's for water, and then temperatures and pressures.